Hi everyone, I'm excited to present to you PaTAT, a human AI collaborative qualitative coding tool with explainable interactive rule synthesis. My name is Simret Gebreegziabher, and this work is done in collaboration with Zheng, Xiaohang Tang, Yihao Meng, Elena Glassman, and Toby Lee. Qualitative coding is an analytical process where researchers have to go through unstructured data in multiple rounds to find patterns and codes in their data that eventually evolves into themes and findings that are then used to answer specific research questions. Because this task is done iteratively and in multiple rounds, it can be time consuming and theoretically unbounded. It also has a requirement for creative code composition from the researchers. Inductive qualitative coding involves identifying patterns in a data, annotating the data with identified codes and patterns, integrating patterns, and evolving them to iteratively identify more patterns and codes in the dataset. This code evolution can also be informed by the researcher's hypothesis, which would be a great input in identifying patterns that best answer the research question. Informed by a formative study, we built PaTAT, a human AI collaborative qualitative coding tool that iteratively gives thematic label suggestions by learning pattern rules from a user's qualitative coding process in real time. In our formative study, we were able to identify 4 key features that researchers value in AI-assisted qualitative coding. Firstly, researchers value having the agency to make the ultimate annotation decision. This involves coming up with labels and being able to accept and reject model suggestions with full autonomy. Researchers also value finding new insight and comprehension of their data through the process of qualitative coding. Because qualitative coding is an iterative and ambiguous process, researchers required accommodation to this nature. The major concern amongst our participants was the fear of missing important data and insight because of the model's input. And lastly, researchers valued having the means to understand the AI's rationale, to verify its soundness and repair it whenever needed. While the tasks of qualitative coding and other forms of data annotation might seem similar, they're actually quite different. The primary goal of qualitative coding is for the researchers to have an understanding of their data and gain more comprehension. However, the primary goal of most data annotation tasks is to come up with high-quality labeled data for machine learning purposes. Secondly, the labels involved in qualitative coding are often ambiguous and subjective, as opposed to the data that are mostly used in data annotation tasks that are usually very deductive and unambiguous. Lastly, in qualitative coding, the user's understanding of their data is continuously changing and evolving, which is often not true in data annotation tasks. Now, this raises another question. Why not just use an end-to-end black box model for qualitative coding? Well, that won't work because one, they lack the support of explanation that users can use to explore and understand their data, and secondly, they lack the transparency to allow users to understand the model. To address these concerns and expectations, we propose an interactive program synthesis approach to learn symbolic representation of codes over neurally generated features, including part-of-speech tags, word stemmings, soft matches, entity type tags, and wildcard. In PaTAT, we use a program synthesis approach. This involves a user showing their intent by providing examples, and the synthesizer would search over a huge program space and come up with patterns that match the user's positive examples and that do not match against the user's negative examples. The user iteratively shows their intent by creating and adding thematic labels to data items. This would look like the user would explore their data and come up with themes to use in their coding. The users can then iteratively, one by one, go through their data and assign thematic labels to their data points. Now, the synthesis involves searching through a huge program space where patterns are combined based on optimizing the information gained to create a pattern that best captures the majority of positive examples while discriminating against user-provided negative examples. As the user annotates data items, PaTAT generates pattern for the selected theme and selects at most 5 patterns that best combined in linear combination most agree with existing user-provided labels and best capture the user's annotated data points. To maintain interpretability, we choose to have at most 5 patterns in the prediction set. Phrases that match the patterns in the prediction set are highlighted for users' understanding. Users can simply hover over the highlights to view what patterns they match, which would align the patterns with concrete data item and assists in tackling the right for the wrong reason challenge in AI assistance. Users also have the ability to filter data based on patterns matched. Users can give feedback to the model either by accepting or rejecting the label suggestions on the data items or by manually deleting a pattern that looks irrelevant. Users also have the option to manually promote relevant patterns to be included in the prediction set. A unique challenge in qualitative coding is that codes would continuously evolve and change. To support code evolution, users can merge, split, or delete themes. Here we show a split theme as an example. Because patterns may indicate the existence of distinct clusters of items that represent various possible code splittings, we integrate splitting with patterns to assist users during code evolution. Now let's look at the evaluation of PaTAT. To understand the performance of PaTAT in capturing the patterns, we conduct an offline performance evaluation. In this evaluation, we compare PaTAT's accuracy with that of a pre-trained BERT model using few-shot learning. The performance of both models generally improves as more data becomes available. The performance of PaTAT is comparable to that of BERT when trained on smaller number of examples. This represents the most common target use case for PaTAT, as the number of items labeled with each theme tend to be small in qualitative coding tasks. To test the usability and usefulness of PaTAT, we also conducted a user study with 8 participants with some sort of qualitative coding experience. The main objective of the study was to simulate the subjectivity, ambiguity, and uncertainty of qualitative coding and compare the behavior and experience of our participants with different conditions. Our results show that participants reported the baseline or the manual condition to be the easiest or to have the higher perceived user control. However, they also reported that PaTAT was more useful and enabled them to learn more about their data set. By providing interpretable pattern, PaTAT was able to facilitate users' understanding of the current state of the model, which in turn contributed to error discovery and repair. Our participants also used these patterns as a way to validate the capability of the system and their own sanity checks. They also used these patterns to repair and modify the model whenever needed. The interpretable patterns also facilitated the discovery of new themes, higher-level trends and connections among the data items, and helped participants form new theories and extract new insights from the data. We explore qualitative coding specifically because it exemplifies a type of human-AI collaborative task that deals with ambiguous and abstract concepts. In this setting, it is important to determine the appropriate intermediate representation of data, user intent, and AI model's current level of comprehension to facilitate an interactive and iterative process of intent resolution, disambiguation, and development of understanding for both parties. This is particularly challenging in qualitative coding because natural language is frequently ambiguous and unpredictable. And it can be hard to account for all possible variations solely using regular expressions. Given the subtleties and nuances that can exist within text, particularly when themes being coded are abstract in nature, PaTAT introduces soft matches within the pattern language that provides more flexibility in the matching process and capture a wider latent space. The patterns are then combined through a linear layer to further expand the matched coverage while still ensuring the model's explainability and the user's ability to validate and correct it. These observations highlight the need for pattern language that can capture more abstract meaning of codes in the design of AI assistants for qualitative coding. We believe that there is a trade-off between supporting abstraction and the ability to enable human reasoning and explainability in this context. In conclusion, AI-assisted qualitative coding and data annotation in ambiguous and subjective settings present the need to continuously sync the human's learning and the model's learning. The different levels of users' mental models should be taken into account when designing interaction strategies. For example, model assists better in data organization during theme discovery versus model would assist by providing label suggestions after initial codebook has been formed. And lastly, tools in this settings should make it easy for users to get feedback and for them to be able to refine and adjust the system whenever needed. Thank you for listening.